In this video, I'm going to present two other types of security policy. The first one is the role-based access control policy. The role-based access control policy is mostly used in commercial applications. The second security policy I will present is the attribute-based access control policy. I will show that this policy is highly expressive. It could even be used to implement the role-based access control policy or the multi-level security policy. So consider a large organization. In such an organization, a security policy based on the identity of users would be cumbersome to manage since the users' roles in the organization tend to change over time. A role-based access control policy is not based on user identity or even user groups. It is based on the roles users have in the organization. And what is a role? A role is simply a job function. The security policy consists of a set of roles to which permissions are attached. So the policy is defined independently from users. It only refers to roles. Once the security policy is defined, then roles are distributed to users according to their job function. A user can receive several roles if he has several job functions. The default security policy is closed, that is, anything that is not permitted is prohibited. One thing which is very important in the RBAC policy is this concept of session. Users enter a session by activating one or more of their roles. When a user logs in, he will choose which of the roles is going to play from the roles he has been assigned, knowing that he can activate one and perhaps even more if he has been assigned more than one role. A process generated by a user inherits the privileges of the roles that the user has activated. This is not surprising at all. An interesting fact about roles is that they can be organized hierarchically with a mechanism of inheritance between them. This is interesting because it allows a better structuring of the security policy. In this hierarchy, specialized roles inherit privileges from more generic roles. For example, roles manager and accountant inherit the role employee. Role supervisor inherits the role manager. The RBAC policy has very often been used to implement a very specific but very common security policy, which is called the separation of duties policy. The separation of duties policy stipulates that if two steps are required to accomplish a critical function, at least two different people must perform them. And by critical function, I mean a function that could lead to fraud committed by an insider employee. For example, the payment authorizing officer should not be the employee making the transfer of funds. Otherwise, that employee could organize some payments for himself. Separation of duties regulations are very common in commercial organizations. RBAC can be used to easily implement such regulation. Let's see how. In the RBAC policy, it is possible to assign constraints restricting either the distribution of roles or the activation of roles. A constraint restricting the distribution of roles imposes that two given roles cannot be assigned to the same individual. For example, do not assign the payment authorization role and funds transfer role to the same employee. Such a constraint is sometimes called a static separation of duties constraint. A constraint restricting the activation of roles imposes that two given roles cannot be activated at the same time by the same individual. For example, you may assign the payment authorization role and the funds transfer role to the same employee, but that employee cannot activate both roles at the same time. Such a constraint is sometimes called the dynamic separation of duties constraint. Of course, a static separation of duties constraint is stronger than a dynamic separation of duties constraint and is intuitively more secure. Let me say a few words about the security policy administration. Administration of the RBAC policy is generally centralized. There is a single administrator. Administering the RBAC policy requires several steps. It requires first defining the roles. This simply means listing the job functions. It requires also assigning privileges to roles. Assigning roles to roles. This is for defining the inheritance hierarchy. For example, as assigning the role employee to the role manager means that the role manager will inherit all privileges associated with the role employee. Role manager will have also, of course, its own specialized privileges. Administering the RBAC policy requires also setting the role distribution or activation constraints. And finally, it requires assigning roles to users. You can find many products implementing the concept of role. For example, SQL implements the concept of role and CLinux as well. As I said, the role-based access control policy is a very common security policy in the commercial organization. The constraints we can define on the distribution or activation of roles provide a simple solution to implement the very important separation of duties policy. In the second part of this video, I will present the attribute-based access control policy. This security policy is highly expressive and allows to include conditions in security rules. I will also give an overview of the XACML, which is an XML-based language standard for specifying attribute-based access control security rules. So in order to introduce the ABAC policy, let me go back to the RBAC policy. The role that a user assumes in an organization is a kind of user's attribute. Therefore, RBAC can be seen as an attribute-based security policy where the only attribute is the user's role in the organization. ABAC is the new generation of access control system which generalizes this concept of attribute. We can base the security rules on the attributes of the subject, on the attributes of the object, and on the attributes of the environment. ABAC security rules are like if-then statements where the condition, the if, is based on some attribute values, and the conclusion, the then, is a permission, a prohibition, or an obligation. ABAC rules are said to be dynamic because they activate when their condition is true. ABAC policy is highly expressive, and ABAC is sometimes called PBAC, policy-based access control, or even sometimes rollback policy. So let me show you a few examples of ABAC security rules. The first rule says that students are permitted to use Wi-Fi between 7 a.m. and 7 p.m. Let's have a look at this rule. Role is an attribute of subject S. Type is an attribute of object O. And time is an attribute of the environment. This second example says that one may use the Wi-Fi from inside the building only. GPS position is an attribute of the subject. It indicates the location of the subject. In security, perimeter is simply a predicate to verify that the location is inside the building. and type is an attribute of object O. This second rule is interesting because it shows that subjects can be granted privileges without authenticating themselves, simply by checking some of their attribute values. In this example, knowledge of the subject's GPS position is sufficient to allow him to use object of type Wi-Fi. ABAC rules activate when their condition is true, so verifying conditions means authenticating attributes. In the example on the previous slide, I used mathematical notation to express security rules. I used predicate logic. Of course, one cannot write security rules using predicate logic. XACML is an XML-based language standard for specifying ABAC rules. However, XACML is a machine-readable policy language. I will not describe it. It's not user-friendly at all. It's difficult to read and write by a human. Writing XACML rules in a user-friendly manner requires a policy editor, allowing the administrator to express rules in a kind of proprietary readable language, possibly graphical, and translate these rules in XACML, which is the standard for processing rules. So the XACML standard defines a machine-readable language for expressing ABAC security rules. This standard also defines a processing model for evaluating access requests according to ABAC rules. And this processing model is interesting. Let me describe it. So this figure describes everything. Assume a user, say Alice, submits a request. The request is to view record 123. The policy enforcement point, PEP, intercepts the request and sends it to the policy decision point, PDP. Can Alice view record 123? The PDP is the intelligent component of the XACML processing system. It can be implemented with an inference engine. The PDP first queries the security policy. It selects all the rules that potentially match the request. It then queries the policy information point, PIP, to retrieve some attribute values. From the rules it has selected, some will activate, others will not, depending on the retrieved attribute values. The PDP resolves possible conflicts between activated ABAC rules and returns the decision access granted. The decision is transmitted to the PEP, which enforces it. That is, it retrieves record 123 and transfers it to Alice. I should not forget to mention the policy administration point, PAP. This is the component that allows the security administrator to update the security policy. On this slide, I have summarized everything that I have just said. When I explained the XACML processing model, I mentioned that conflicts may arise between rules. This is because the ABAC security policy can include permissions and prohibitions. The XACML standard defines several strategies to solve conflicts between rules. Permit overrides means permissions have the priority in case of conflict. Denied overrides means prohibition have the priority in case of conflict. First applicable means the first rule that activates in the sequential order of writing has the priority, and so on. You can read more about these strategies at the URL written on the slide. I also mentioned that ABAC supports the concept of obligations. However, obligations are difficult to enforce. In fact, it's impossible to enforce obligations by a security mechanism unless these obligations must be fulfilled by the system. XACML supports the so-called provisional obligations. And XACML defines provisional obligations as obligations that must be fulfilled by the system, that is by the PEP, Policy Enforcement Point, before or after an access has been granted or denied. So here is an example. Whenever an access is granted, the PEP must log that access. Before or after is not important. So XACML supports only this concept of provisional obligations. That is, obligations that the PEP must enforce before or after an access has been granted or denied. So this is a very specific type of obligation. Here also I included a link if you are interested to know more about obligations in XACML. So in this video we reviewed two important security policies, which are the role-based access control policy and the attribute-based access control policy. There are other security policies that I could present. I would like to mention two of them so that you can learn about them on the internet or in book. The Chinese Wall Security Policy is a specific mandatory security policy which is used to prevent conflicts of interest. The Usage Control Policy is a security policy to control the use of information in digital right management systems. I encourage you to read up on these two policies.